Welcome to Arrays in Java. In programming, arrays are used to store multiple variables in one single variable. This makes accessing and storing a range of data much easier than if we were just trying to use variables alone, because you can access all the data from one single variable. In Java, however, when we're creating an array, all of the variables have to be the same type. We cannot have an array that has one string and one integer. So, to clarify, in Java, all the values in an array have to be of the same data type. Declaring an array. How do we declare an array in Java? In Java, when we declare an array, we have three parts to the code. Firstly, we have the data type followed by square brackets. The square brackets here tell Java we're making an array of this data type. Next, we have the array name. This is what we're going to name the array, just like how we name variables. Lastly, we have a set of curly braces, and inside them we have our values separated by commas. For the data types, we can have either just primitive data types or objects. So, for example, we can have an integer array, char array, string array, the list goes on, but those are some examples. For the array name, it could be anything you want to name, just like a variable, array1, box, chicken holder, anything. For the comma separated values, these are just the values that we want to put in the array, each of them separated by a comma. Here you can see in our array of integers, we're putting in the values 1, 2, and 3, and so they're placed inside curly braces and separated by commas. For our char array, we're only inputting h. This is just to show you guys that you can actually make an array of only one value, and although there isn't much use to this, you can do it. And here, an example for our string array, hello and potato. Two values, separated by a comma, in between curly braces. Here I am on a website called Java Visualizer. This is very useful for beginners or for anyone who's learning a new concept. It shows what's happening a bit more behind the scenes and goes through the code line by line. So if you are stuck at any point, you could follow along on this website. And if you want to practice some more on the concepts we review in this video, I recommend going here as well. So here we're just going to declare an array just like how we were doing a second ago. So let's make an array of integers. So int square brackets, we'll name it array1. Set it equal to some, let's make the values 8, 9, 7, and semicolon. Let's also make an array of strings. So string array equals by popcorn, semicolon. There. So now once you click visualize execution, if you guys are on the website with me, then you'll be able to see what happens line by line. So after this line gets run, you can see that an array is created and it has all of our three values that we put in. Next, after we run the string array line, you can see that a string array is created and it has the same. By popcorn, the values that we put in are now being shown on the screen because that's how we initialize the array. One important concept of arrays is the length of the array. When we create an array, we have to declare the array length either implicitly or explicitly. What we just did right now was declaring the length implicitly. We didn't say a specific number, but we did give the values, and because we gave the values, Java said, okay, they're giving me 3 values, so the length is 3. After you create an array, you can't change the length. The length is set, you can't increase it or decrease it without creating a new array. Additionally, you can't input more values than your selected length. If we make an array of length 3, we cannot try and input 4 values because there's nowhere to put the values. The reason we have to declare the length on creation of an array is just so we can tell Java how much memory we're going to be using. That's also the reason why we can't add more values than our length, because when we initialize the array, we tell Java we want space for only 3 values, but then we try and input 4 values and there's no space, so that won't work. Here's an example of a simple array with the values 1, 4, and 5. As you can see here, this array only has 3 values, meaning this will have a length of 3. This is important because sometimes in programs, we don't actually know the values we're going to put in. Sometimes we have to initialize the array at the beginning, but we're actually going to change the values by the end. So in order to do that, sometimes we need to make an empty array at the beginning. To make an empty array, we need to know the length. After we make an empty array, we can change the values along the way as long as we're not trying to mess with the length of the array. If we're trying to make an empty array, this is how we would do it. It's the same as before, data type, square bracket, array name, but instead of setting the values after, we would say equal sign, new, and then our data type, and then the length. Okay, back to our visualizer, we're going to try and make an empty array. Let's say we know we need an array of length 3, but we don't have the values. So we'll make an integer array, array 2 equals new int square bracket 3 square bracket. Now, once we run the code, we should see an empty array of length 3. We should see an array with space for 3 values. And as you can see here, array 2 points to 3 values. One concept to note though is that different data types have different default values. If we make a char array and set it to an empty array of chars, with length of 3, then instead of actually being an array filled with zeros, it'll actually be an array filled with this. This value doesn't matter. This is basically empty space but for char. But this is just to show that for the different data types we have different default values. Because string is an object, in this case, any object will always have the same default value. And the default value for an object is actually going to be null. That's just something to note. Let's say we have this array, and we want to get the first value at this array and store it in an integer variable called a. Before that, we need to understand one simple concept. This is our array that we just initialized. Array 1, 1, 4, 5. So this is essentially our array. In the English language, when we talk about this array, we say, okay, that's the first value, that's the second value, that's the third value. The thing is, in programming, we index things starting from 0. What that means is, the first value is actually the 0th value. The second value is actually the first value, and the third value is actually the second value. You don't need to know any reasoning behind this is just how it works in programming, so this is something to remember. And remember, each of these is called an index. So the value at index 0 is 1, the value at index 1 is 4, and the value at index 2 is 5. These values are specific for this array, but indexing works the same in all arrays. When we want to get the value of an array, we write it like this: array name, then index. So let's say we want to store our first value, or 0th index value, into an integer called a, and a is a variable. This is how we would do it. Int a equals array1 0, because 0 is the index for the first value. Hopefully you can understand how that works. That's us accessing the first value because we're using the 0th index. To show an example in the visualizer, I just redid our array here, and we'll make a new integer, int a equals array1, and then our index 0 is that. Now we'll just print out the variable, just a. So now when we print a, we should get the first value, which is 1. So if we go all the way to the end of the code, we hit last, and you can see program output is 1. And you can see here that a is set to 1. This is because we set a to the value at index 0 of array 1. This is an important concept, so if you don't understand, you can always go in the visualizer and experiment a bit and make sure you're writing it correctly, just like you can see here. So let's say we have this array and we want to change the first value of this array to a different value. What I mean is, let's say we want to change 1, the value 1 of this array, to 2. So we want the array to go from 145 to a 245. How would we go about doing this? It's very simple actually. It's the same way that we were accessing the data before. We're going to do it the same. We're going to say array1 0 equals 2. So we're saying the value at the 0th index of array 1 is going to be set to 2. So we're changing the value from 1, which is at the 0th index, to 2, which is now what the value is at the 0th index. Before we go any further, we need to go over how arrays are actually stored in memory in Java. This is important because when you're trying to do something as simple as copying over an array, it's not as simple as it is with variables. Let's say we have this array, array1. It's shown like this, as we've explained previously. In Java, data is stored at specific addresses. This is just so Java can keep track of where data is, otherwise we won't be able to access it. In this case, I set arbitrary values to the addresses, but one thing to note is that they are in sequence. One thing with arrays is that they don't actually store the array in there directly. This variable, array1, actually stores an address. It just stores one address, and that's A100. A100 is an example here, but It stores the address of the first value of the array. It knows which values are part of its array from this first address because we gave it a length. So because we told Java, okay, our array has length 3, now it says, okay, starting at A100, any value within 3 values, because length is 3, is going to be part of our array. So that's how we go about doing it. Just remember that array variables only store the address, not the actual arrays themselves. Copying arrays. Let's say we have our normal array that we've been using, has these values at these addresses, and we have another array, array 2. We're setting it to 0, 0, 0, and we're going to say that it starts at A200, not A100, so it's a completely different address, and the values inside are 0, 0, 0. Just like we mentioned before, array 1 links to A100, the address at the first value. Array 2 links to A200, the address at the first value of the second array. We have a problem though. We want to copy the values from array 1 into array 2, and then change the second value of array 2 to 3. To simplify, we want to make a copy of array 1, set it to array 2, and then change one of those values. This should not affect array 1 because we're making a copy. In this example, we want to change the second value, or the value at the first index, and we want to set it to 3. So what we want to do is, this should all be copied over. This is going to end up being 1, 4, and 5, and then we want to change this 4 that's copied to a 3. The thing is, when we're using normal variables, we just use the equal sign as an assignment. So if we want to set a equal to b, then we just do a equals b, and then that copies over the value from b into a. In this case, we're going to try the same. Array 2 equals array 1. This copies the value from array 1 into array 2. The problem with this is that it actually copies the address value. Array 2 actually loses A200 and becomes A100. So now array 2 is pointing to A100. When we try and change array 2's first index value to 3, we're actually changing the 4 to the 3. That would be fine, except array 1 is still pointing to that memory address. So you're changing the value in array 1 and array 2 because they're both pointing to the same array. Even though we try to copy over the value from array 1 into array 2, this does not work because we're only copying the address over. One thing you can do is actually get the length of any array you have initialized. Let's say you want to get the length of array 1. We would simply write array1 dot length. And now that's stored in the variable length. And now if we print it out, it should print out here at the bottom 3. And the value 3 is stored in length. That's just a function of arrays. You can write dot length and you'll get the length of the array. If you want to copy an array into another variable, what you can do is write a for loop where our starting variable is I, we set it to 0, and the loop runs while I is less than the length of the array. Okay, so in the array, we're going to have this one line. Array 2 I equals array 1 I. So for each I, we're going to copy the values from array 1 into the spot of array 2. So when I is 0, then the value array 1 of 0 goes into array 2 of 0, which makes that 1. The same goes for when I is 1. The value at index 1 of array 1, which is 4, is going to go into array 2 at index 1. Just going to set that value to 4. And lastly, when I equals 2, then array 1 of 2 is 5, and array 2, index 2, will be set to 5. So there you go. One thing to remember though is make sure your I is less than the array length. If your I for some reason becomes equal to the array length, then you're going to get an array out of bounds exception. In this case, the array length is 3. So then if I is able to equal array length, then I can be 3. The thing is, if I is 3, we're going to try and access array 1 with index of 3. However, as shown in the previous slide, since we start indexing at 0, then we don't have an index of 3 because this is going to be the 0th index, and then the first index, and then the second index. And then we're trying to access the third index, but there is no third index, so we're going to get an error. So make sure to set I less than array length and not make a loop where it can be equal to array length. And in this case here, you can see what the final values will be set at. They're both different addresses, so none of them are messing with each other. And now don't forget, we were trying to set the second value of array 2 to 3. So now if we run that line like we did previously, array 2 1 equals 3, then we're just going to change this value from 4 to 3, and we're not affecting the first array, and we're only affecting the second array. So this is a successful way of copying arrays without affecting one another. Lastly, we're going to go over multidimensional arrays very briefly. Multidimensional arrays are essentially arrays of arrays. Just like previously, we're going to write it as data type and then square bracket. The thing is, if we're making a two-dimensional array, we're actually going to include another pair of square brackets after the initial pair. The same goes for any amount of dimensions. If you're doing a four-dimensional array, it's going to end up being 4 square brackets. And after that, it's very similar to what we did, except where the values would go, we have comma-separated arrays. So instead of comma-separated values, we actually have comma-separated arrays. If that doesn't really make sense, we're going to go over an example in a second. Here's an example of us declaring a two-dimensional array called array multi. As you can see here, we have curly braces, and inside we have multiple arrays, each of them set by their own curly braces, and they all have comma-separated values inside of them for their own arrays. On the screen, you can see a simple example of us initializing a two-dimensional array. You can see we're using the integer data type and then 2 square brackets after to denote that we're doing a two-dimensional array. After that, you can see we're naming the array array multi. We're actually setting the value of array multi to an array holding 3 different arrays and each of them having their own values. One thing to note is that the arrays themselves don't have to have the same length as each other. This is just a coincidence in this example, but let's say array multi had 3 arrays and 2 of them were length 3 but one of them was length 2. That's perfectly fine. As you can see here, array multi only stores one address, but that address leads to A100. You can see that multidimensional arrays work very similar to how arrays work. We're just putting addresses inside of addresses. So in this case, we're pointing to A100. A100 is the first value in 3, but the value at A100 is actually A200, and A200 points to this new array. Same goes for A101. The value in that memory address is actually A300, which points to another array starting at address A300. And lastly, same goes for A400, where it's the same thing. Accessing data in multidimensional arrays is very similar to how we access data in one-dimensional arrays. All we have to do is write the array name, and in this case there's actually going to be 2 indexes. One of them is going to be for which array it's actually going to be in the array of arrays, and then the second index is the actual index of the value in that secondary array. One way to visualize it though is if we have a two-dimensional array, you can actually visualize it like this, where it's a sort of grid-like structure. This is useful because now we have the indexes of the different rows and columns. And that might not mean much to you, but when I pull this up, it'll probably make much more sense to you. This is a great way to access multidimensional arrays with a more visual concept in mind than just the idea that an array is inside an array. Thank you for watching. That's the end of the video. If you do need more help, I really recommend practicing in a Java visualizer just like I was using previously. It's really useful for beginners and trying to get your head around tough concepts. If this video helped you in any way, you can show your support by subscribing, or you could turn on the notification bell to be notified whenever I make any future videos that might be helpful to you. Here I've linked a playlist of all my Java videos, and it'll be in the description as well.